Welcome to Module A3 of the NATMed Training Program, focusing on how full water cycle nature-based solutions can move beyond individual pilot projects and achieve wider impact through replication and upscaling. NATMed places strong emphasis on participatory governance and clustering strategies, with particular attention to how successful solutions can be transferred to new contexts. The Replicability Plan, together with the Participatory Governance Plan, forms the core training material for this session. Together, they aim to boost social innovation and ensure continuous knowledge transfer of NATMed's main outputs and experiences. In this module, you will learn why replication and upscaling of nature-based solutions are essential for achieving broader impact and supporting policy uptake. You will explore the key phases, methods, and tools needed to plan and implement NbS replication in a structured and effective way. The module will also introduce approaches for assessing institutional and governance readiness, helping identify whether conditions are in place to scale solutions successfully. In addition, you will learn how to adapt nature-based solutions to diverse local contexts to ensure technical feasibility, social acceptance, and long-term sustainability. Finally, the module will highlight how clustering, networking, and communities of practice support replication, mutual learning, and long-term sustainability of full water cycle nature-based solutions. This module is designed for a wide range of actors involved in scaling and replicating nature-based solutions. It is particularly relevant for public authorities at national, regional, and local levels, as well as decision-makers responsible for planning, funding, and policy development. It also addresses researchers, farmers, business actors, and other stakeholders who play a role in adapting, implementing, and sustaining full water cycle nature-based solutions in different contexts. Why replication is essential if nature-based solutions are to influence policy and practice beyond individual projects. Replication allows climate action impacts to extend beyond pilot areas, supports policy relevance by linking local results to regional and EU strategies, and improves efficiency by building on solutions that are already tested. It also strengthens social innovation and governance, as scaling NbS depends on trust, participation, and alignment with stakeholder needs. Finally, networks and clustering help amplify impact and accelerate learning across regions. Overall, NATMed's experience shows that replication is not only about copying solutions, but about transferring knowledge, governance approaches, and implementation processes to new contexts. The importance of replication becomes clearer when looking at how full water cycle nature-based solutions performed across different pilot regions. Testing full water cycle nature-based solutions across very different contexts showed that diversity strengthens learning. Replication does not require identical conditions, but rather an understanding of how solutions perform under different climates, socioeconomic settings, and governance systems. Another key lesson is the value of adapting existing infrastructures. Building on reservoirs, irrigation canals, or wastewater systems, rather than creating entirely new ones, often proves more cost-effective and politically acceptable. Also keep in mind that clear baselines and systematic monitoring are non-negotiable. Demonstrating benefits such as water savings, groundwater recharge, or biodiversity improvement is critical for building credibility and convincing policymakers to support replication. Governance barriers are real and vary from place to place. Institutional fragmentation, regulatory gaps, or unclear responsibilities can limit replication if they are not anticipated and addressed early. Community engagement also emerged as a critical factor. Involving farmers, municipalities, and citizens increased acceptance, trust, and long-term sustainability. This shows that replication is not only a technical exercise, but also a social innovation process. Finally, scaling is faster and more effective through networks. NATMed highlighted the importance of clustering, communities of practice, and collaboration with other projects and institutions to share knowledge, overcome barriers, and adapt solutions to new geographical and socioeconomic contexts. Replication is not a single action, but a structured and iterative process. Based on its experience, NATMed designed a four-phase approach to ensure that replication of full water cycle nature-based solutions is systematic, evidence-based, and adaptable to different local contexts. This structured pathway helps avoid fragmented or ad hoc replication and supports cities and regions in aligning technical, social, and governance readiness. By following these phases, NATMed shows how it is possible to move from site-specific pilot interventions to broader Mediterranean strategies for scaling nature-based solutions. The first phase focuses on NBS diagnosis, where baseline conditions are collected, indicators are defined, and the replication context is clearly set. The second phase addresses barriers and facilitators, assessing economic, social, cultural, technical, environmental, and legal conditions that may enable or constrain replication. The third phase is the NBS catalog, which brings together full water cycle nature-based solutions tested in NATMed, as well as complementary solutions from other European projects. Finally, the fourth phase translates this knowledge into concrete recommendations, producing guidance to support replication and upscaling in new contexts. But how the replication phases should be used in practice. The four-phase structure should be used as a roadmap when planning replication. Each phase builds on the previous one, and the outputs should be integrated into training activities, planning processes, and decision-making. At the same time, there are some common pitfalls to avoid. One is jumping directly to implementation without first carrying out proper diagnosis or barrier and facilitator analysis. Another is treating the NBS catalog as a static list, rather than as a living reference that should be updated, adapted, and expanded as new experiences emerge. Following the full-phased approach helps ensure that replication is realistic, context-sensitive, and sustainable. For nature-based solutions to move beyond pilot projects, the right capacities need to be in place at multiple levels. Replication is not only about having technical designs. It also requires governance skills, social engagement processes, financial understanding, and the ability to monitor and adapt solutions over time. Successful scaling depends on strengthening capacities across technical, institutional, and social dimensions. From a technical perspective, stakeholders need knowledge on the design, operation, and monitoring of nature-based solutions. Governance and coordination skills are also critical, as replication requires managing multi-actor processes involving public authorities, water agencies, farmers, and other stakeholders. Community engagement capacities are equally important. Skills are needed to involve citizens meaningfully in co-design, maintenance, and monitoring, ensuring acceptance and long-term sustainability. In addition, financial and business capacities are required. Municipalities and communities need to understand funding models, incentives, and opportunities linked to nature-based solutions, including entrepreneurship and public-private partnerships. Finally, replication is strengthened through knowledge transfer and networking, where learning exchanges between regions help reduce risks and accelerate uptake. Based on these needs, NATMed has developed training modules, participatory governance plan, decision support tool, and clustering activities to support capacity building and facilitate the replication and upscaling of full water cycle nature-based solutions. Beyond technical and human capacities, successful replication of full water cycle nature-based solutions also depends on whether the institutional and governance context is ready to support them. Institutional and governance readiness refers to how well existing policies, institutions, and coordination mechanisms in a city or region can support the implementation of such interventions. Even well-designed nature-based solutions cannot succeed if the governance framework is fragmented, unclear, or lacks the necessary capacity. Readiness is therefore not only a technical issue, but also an institutional and organizational one. In NATMed, governance readiness was assessed using several complementary approaches. These included stakeholder engagement activities and local sessions, as well as the development of participatory governance plans that mapped institutional barriers and proposed practical solutions. Governance readiness was also examined through dialogue within the Mediterranean communities of practice established in each case study area. In addition, the IUCN Global Standard for Nature-Based Solutions was used. Particularly, its criterion on inclusive, transparent, and empowering governance provided an indirect but structured assessment of governance conditions. Finally, a barrier and facilitator matrix was applied to systematically identify what supports or blocks NBS implementation across political, economic, social, cultural, technical, environmental, and legal dimensions. All these materials are available on the NATMed website. In addition to the approaches used in NATMed, there is a growing body of methods in the wider NBS and resilience literature for assessing institutional and governance readiness. Policy and institutional readiness assessments focus on how national or regional policies explicitly reference nature-based solutions, and whether legal frameworks allow flexibility for hybrid gray-green solutions. Capacity and institutional analysis tools examine readiness at different levels, including institutional, organizational, and individual capacities, helping identify where targeted support is needed. Multi-level governance diagnostics assess how well coordination works between national, regional, and local levels, and whether policies are integrated across sectors such as water, agriculture, energy, and biodiversity. Governance quality indicators are also widely used, focusing on aspects such as transparency, accountability, participation, and enforcement capacity, often assessed through surveys or expert judgment. Finally, comparative case studies and benchmarking allow regions to learn from contexts where nature-based solutions are already mainstreamed, helping identify enabling and blocking governance conditions. Several important governance lessons emerge from the implementation of full water cycle nature-based solutions. First, clear mandates and responsibilities are essential. NbS planning, permitting, and long-term maintenance become very difficult when roles are unclear or fragmented across institutions. Second, governance gaps can act as major barriers, even when technical solutions are well designed. Unclear laws, overlapping competences, or weak enforcement can significantly slow down or constrain implementation. Inclusive and participatory governance also proved critical. When stakeholders are meaningfully involved, solutions gain legitimacy, local ownership increases, and the risk of failure is reduced. This was particularly evident in cases where structured co-design and dialogue helped align different interests. Cross-sector cooperation is another key lesson. Integrated water management requires coordination between water, agriculture, environment, energy, and municipal authorities. Without this coordination, NbS struggle to deliver their full benefits. Finally, applying the IUCN Global standard confirmed that strong governance processes are a prerequisite for long-term success. In contexts where governance structures were clearer and responsibilities better defined, alignment with the standard was higher. Where legal or institutional ambiguities existed, additional effort was needed to adapt and stabilize governance arrangements. This slide summarizes key actions to take and pitfalls to avoid when assessing institutional and governance readiness for replication. In terms of actions, governance structures should be mapped early, including ministries, municipalities, basin authorities, and other relevant actors. Establishing multi-actor governance committees helps ensure that farmers, citizens, NGOs, and public authorities are all involved in decision-making. It is also important to apply the 7-dimension barrier and facilitator matrix early in replication planning, so that political, economic, social, technical, environmental, and legal conditions are assessed in a structured way. Aligning NbS planning with existing water laws and environmental regulations is essential to avoid delays and legal barriers. At the same time, there are pitfalls to avoid. Ignoring legal compliance issues, such as permits or wastewater reuse regulations, can significantly delay or block implementation. Overlooking the limited capacity of local institutions for operation and maintenance can undermine long-term sustainability. Finally, designing nature-based solutions without clearly defining ownership and responsibilities often leads to governance failures during implementation. With governance conditions in place, attention can now shift to how full water cycle nature-based solutions are scaled from individual pilot sites to wider adoption across regions or at the Mediterranean level. Strategic planning is essential to avoid the pilot trap, where projects remain isolated instead of informing broader change. The first step is local replication. Pilot sites act as learning laboratories, and the priority is to document what works, including technical designs, KPIs, and governance arrangements. A key risk is treating pilots as standalone experiments without planning for replication. The second step is regional upscaling. Many Mediterranean water challenges are shared across borders, so solutions must be adapted to different legal, hydrological, and institutional contexts. Peer-to-peer exchange and regional platforms support this process, while copy-pasting solutions without adaptation should be avoided. The third step is Mediterranean mainstreaming. Long-term impact requires embedding NbS into policy frameworks and funding schemes. This means engaging policymakers early, aligning with EU and national strategies, and moving beyond short-term project-based financing. Communities of practice play a key role in supporting replication and upscaling of nature-based solutions. By bringing together diverse actors, communities of practice facilitate knowledge sharing, peer learning, and capacity building. They create spaces for collaboration and networking across institutions, regions, and sectors, and provide a safe environment for collective problem-solving and co-design. Importantly, communities of practice support replication by ensuring that successful practices tested in one location are shared, discussed, and adapted elsewhere. They also encourage innovation by exposing participants to different perspectives and help build long-term communities that can outlast individual projects of the case study areas. These communities supported engagement, co-design, and validation, and contributed to replication planning by linking stakeholder feedback with technical, governance, and monitoring outputs. More detailed information on the MEDCOP methodology, citizen engagement, and co-design procedures is provided in Module B2 of the NATMed Training Program. If no two places are the same, the key question becomes, how do we adapt nature-based solutions to local contexts while still enabling replication? Even when NBS concepts are transferable, their design, implementation, and management must reflect local environmental conditions, socioeconomic realities, cultural practices, and governance frameworks. Experience from NATMed showed that adaptation is essential for successful and sustainable full water cycle nature-based solutions. Hydrological differences matter. Mediterranean sites face very different challenges, such as drought, water scarcity, salinity, pollution, or irrigation demand, and NBS must respond accordingly. Socioeconomic context also drives acceptance. Farmers' willingness to participate, dependence on tourism, or market incentives strongly influence what is feasible. Governance and policy frameworks further shape solutions, including water reuse regulations, land tenure arrangements, and enforcement capacity. Cultural factors also play an important role, as stakeholder perceptions and traditional practices influence whether NBS are embraced or resisted. Overall, replication is not about copying solutions, but about adapting them to local realities. Adaptation should always start with a site-specific diagnosis, covering hydrological, soil, socioeconomic, and governance conditions. Co-designing nature-based solutions with local stakeholders is essential to ensure social acceptance and long-term viability. Technical designs must also be adapted to local legal frameworks, institutional arrangements, and available financial and human resources. Finally, monitoring feedback loops should be used to refine solutions over time, allowing nature-based solutions to evolve in response to real-world conditions. At the same time, there are clear pitfalls to avoid. Copy-pasting nature-based solutions from other sites without considering local context often leads to failure. Ignoring sociocultural perceptions or livelihood needs can undermine acceptance, while designing solutions that exceed local institutional or financial capacity risks long-term unsustainability. Overall, adapting nature-based solutions requires both a strategic perspective to ensure replication remains context-sensitive and a practical process to guide implementation step by step. For this practical process, trainees are encouraged to refer to Module B1, Implementation Guidelines for FWC-NbS in the Mediterranean. Replication is strengthened when nature-based solutions are supported by structured tools and internationally recognized standards. These tools help ensure quality, consistency, and credibility, while also supporting adaptation to new contexts. In NATMed, several complementary instruments were used, covering different dimensions of replication, from quality assurance and governance to technical design, decision support, and financial readiness. Detailed guidance on how to use each of these instruments is provided in dedicated training modules within this program. Replication and upscaling of nature-based solutions do not happen in isolation. They are accelerated when projects and cities cluster with others, build networks, and align with European policy frameworks. Clustering refers to joint activities with other projects, which help create economies of scale, shared learning, and greater visibility. Networking goes beyond the project consortium and connects municipalities, researchers, businesses, and citizens. Aligning NBS efforts with EU policy frameworks such as climate, water, and biodiversity strategies ensures relevance, increases access to funding opportunities, and supports long-term policy uptake. Together, these mechanisms create bridges between local practice and large-scale adoption. This brings us to how clustering and networking work in practice to support replication. They enable knowledge transfer by pooling monitoring results, tools, and lessons learned across projects, reducing duplication of effort. Joint activities, such as workshops and exchanges, strengthen institutional and technical capacity. Policy alignment increases legitimacy, making local NBS more attractive to funders and decision-makers. Networks also allow scaling to move across borders, from local to regional and international levels. Importantly, clusters and communities of practice can outlast individual projects, supporting the long-term sustainability of replication efforts. In NATMed, this approach was taken further through the creation of SustainMed, a clustering initiative developed together with the Prima projects RMed and SalaMed. SustainMed functions as a long-term platform for collaboration on sustainable water management in the Mediterranean, designed to continue beyond the lifetime of individual projects. Within this framework, NextGen 4Med was launched to specifically engage and empower young water researchers and practitioners across the Mediterranean. By building a multidisciplinary network, organizing events, and maintaining an open space for exchange and visibility, NextGen 4Med extends NATMed's results to a broader and future-oriented community. We encourage you to join this vivid community in LinkedIn. To make effective use of clustering and networking, there are clear actions to take and pitfalls to avoid. In terms of actions, it is important to join EU or regional NBS clusters and platforms early, link replication strategies to European policy agendas to unlock funding, and engage with networks beyond the project consortium, including cities, utilities, NGOs, and research organizations. At the same time, working in isolation limits impact. Treating clustering as a tick box exercise rather than a replication accelerator reduces its value. Finally, overlooking policy alignment risks losing long-term institutional and financial support. When used strategically, clustering and networking are powerful tools for turning pilot projects into lasting, large-scale change. With this, we conclude the module A3 on replicability and upscaling of full water cycle nature-based solution projects. For access to all NATMed training modules and other useful resources, please visit our website. Thank you for your attendance.